Welcome. And I'm going to talk about security in software development, like not exactly about like technical security, but also about social security. And I'm not talking about social security numbers, but security in psychology of the users and of developers and of clients, like of everyone who is involved in the software development. So a few words about me. I'm Ruby engineer at Blux, who is apparently one of the sponsors of this conference. And I'm also a teacher at Wrocław University of Science and Technology, because it's a new name. I'm mainly a teacher of laboratory, so I'm doing security laboratories at the university across the street. So if you want to catch me, like at the bottom, there's my email. If you have any comments, you can send any notes about this talk, if you like it or not. So before we begin, I'd like to have a few rules about software development. So rule number one, like software is never done. It's a process. So I have never finished a project, or actually I have finished a project, but I have never finished a software, because it's always something to be done, it's always something to be refactored, it's always something to be fixed. And even though you think that the software is done at the end of the project, it's not, trust me. And because of that, there's other rule, which is software is broken. By definition, let's not discuss that. And this presentation is going to be a proof that software is broken. Not only your software, but software you're using, the code you wrote, like everything is broken by definition. So I'm gonna have like 3 parts of this talk. So the third part is about communicating with the client. So the project starts, the client comes to you and he says that, I want to have an app that does X, Y, Z. All right, like in each app, there is going to be some kind of authorization, some kind of authentication, some kind of like knowing who the user is or what the user can do. So basically, there's a conflict between security and the client, because the client says that typing passwords break UX. I don't want users to type passwords on my mobile app, because typing passwords on mobile app is pain in the ass. And he also says that I want to have PIN code to the app. Like that's 30% of the apps on the market. They're using PIN codes because it's easier to type the PIN code than the password. All right. This is the client. You are only an engineer, maybe you are a software analyst, someone like that, but the client says that this is the hard requirement. I want to have PIN code. What we can do about that? Like, PIN code is not really secure, because you can have like more digits in the PIN code. You can have 8 or 10, but it doesn't meet the requirement that the client wants users to be able to log in quickly. So like 4 digits, it's like 90% of the users going to set the PIN code to 4 digits. Probably 1, 2, 3, 4, or the birth date. So there is also the other question, like how do you want to store the PIN codes in your app on the backend? If you're thinking about having like bcrypt or MD5 or SHA or anything like that, basically it won't work, because if PIN code is 4 digits, anyone can break it, no matter how strong the hash is. So it doesn't really matter if you store the PIN code in plain text or in the hash, because there's only 10,000 of possibilities to break the code. Anyway, there's one important question though, where the app is going to be used. So if this is a mobile app, you can presume that people are going to use the app in public places. So you can say that anyone can look the PIN code that you're typing in your phone when you're driving a bus or something like that, or in a tram. That's okay. So if you want to persuade the client that, okay, let's make the PIN code longer, so anyone can have like more secure PIN code to your app. And here's what happens when you have a longer PIN code. It's like 64 digits in the PIN code. So is it secure or not? It's not, because it was recorded. And now you can tell what the pin code was. And that's why actually pin code sucks. But the client says that there must be a pin code, so sorry about that. But what more you can do about improving the security of the app, having in mind that the client still wants the pin code? To answer that, let's talk about the authentication. There are three factors of authentication, actually. If you're talking about multi-factor authentication, there are only three factors. It's something you know, something you have, and something you are. So the password, the pin code, is something you know. Your fingerprint is something you are. So Touch ID on the iPhone or something like that. And RSA token or Google Authenticator or something like that, this is something you have. So if you want to improve the security of the app, you should probably have more than one factor. Okay, so the client says, I don't want users to type a second authorization factor like Google Authenticator code or touch the finger, because the app is not going to be used on iPhone only. Okay, so what you can do about that? There is one other possibility that's the story of the project I was working on some time ago. So the other possibility was to bind the device with the account. So only the first login is using multi-factor authorization, and all the other ones are using only PIN code. That's fine, but still, you can't really authenticate the device. Because I don't know if you guys are working in mobile industry, but the Apple says that you cannot identify the device. So if you cannot identify the device, you cannot have multi-factor authorization on the same device using only the app. You have to have some kind of third-party code like Google Authenticator. And that's not going to happen. So this is one of the problems that is between you and the client. And next one, the projects go to the next stage. There is analysis of the requirements, of the other requirements. But still, there's a second part, so it's you and the world. What does it really mean? It means that out there, internet is evil. Out there are people that are trying to break our application, and they will succeed eventually. So if you don't want to end up on the front page of Daily Telegraph that your account was broken on your app, actually, because you are writing the app and someone hacked your server. They took over your accounts. This is what happens. This is what happens when a major software is being broken and the PR tries to fix it up. So this is Twitter freezes millions of accounts after password leak. What else can they do? They need to force users to change passwords. But it's not the problem that that the passwords of your application are leaked. The problem is that you allowed someone to know the password of the users. And let's not talk about that you have hashed passwords or something like that, because anything can be broken. We have so much computing power right now that actually breaking a password is something like 1 cent per 100,000 hashes. It's something like that. Anyway, so passwords will leak. And if your database is not going to be compromised, someone else is going to be. And the user may have the same password in other app and in your app. So it is your problem when Dropbox was hacked. Okay, so, and why does it all happen? It happens because your app is compromised because software is broken. Something is broken about your code. Or maybe something is broken about the code that you're using. Something is wrong about Nginx, something is wrong about Postgres, whatever. And this is not the only reason why users are afraid of using any kind of password, and they are lazy because they are using the same password. So password leakage is not only reason why you should carry, because there's a bunch of sites like that. You want users to check if the password is okay. Like this is top 5 of the pages with the phrase secure password. So if you're not going to use that page, someone will. And someone will type the password that is in your application. And right, so what you can do about that? Everyone knows that 1, 2, 3, 4, 5, 6 is the default password for the most of the users. Like this is the top 10 passwords. So you could do something about that. Like this is the actual use case of the app I was working on. You can download the full database of passwords, the full database of password hashes. And when the user logs in, you can compare his password with the database and tell the user that his password is compromised. Like that's the only reasonable way of solving the issue of other people's problems. And having a salt in passwords, in password hashes actually, is not a solution because salt doesn't solve the problem of password cracking. It solves the problem of rainbow tables. So you may all know that having a salt is a good practice for the password, for bcrypt, for MD5, for SAH, for SHA. Like this is not a silver bullet. So if your database was leaked, it really doesn't matter if the password is salted, peppered, or anything like that. And there is a third part of software engineering. Like we have the client, we have the evil world, and we have the engineers. So this is something that actually affects you the most, because we are all software engineers, and we are all using Ruby. And like you said that Ruby, as interpreted language, doesn't have as much bugs, and it's harder to write a buggy code in Ruby than in any other language. That's actually not true, because even hello world in Ruby, which is like one line, in fact, it's like 8,000 lines of code that is going to be run on the server. And which means that 99.999% of the code is not yours. This is the statistics of CVEs on cvedetails.com. Like, you can see that this is for Ruby. Ruby is broken by definition. Any version of Ruby. The older version, the worse. But as you can see, like in 2017, there was 11 issues with security, including code execution. And this is only for core Ruby MRE. But also you are using like 20 to 30 games in your app. How many of you have ever checked the source code of the game if it's working okay, if there's no problems with using that? 3%. All right, and how many of you who check the code of native extensions? 30% of those who checked the code at all. So like, this is a really good result. But still, Ruby is single process. So if you have native extensions in Ruby, you are actually running someone else's code in the same process as your application and business logic. And I'm not talking about like, all right, so let's not use, or let's check the code before we use, because it's impossible. You can't really go with the code and check every line of the code and understand every line of the code that is being run in your application. That's simply not possible. You have to trust. And by trusting, like, those graphs are for Ruby. This is Ruby on Rails. So the bugs are much, much more common, and there is more of them. And that's because Ruby on Rails inherits bugs from Ruby. So if there is any bug in Ruby, it's also a bug in Ruby on Rails because it's Ruby. So All right, so one side note, there's only 2.16, there's no 2017 in this chart because they have stopped recording the Ruby on Rails bugs because the community asked them not to show that, which is silly. But. And in the same time, they have boosted up the bounty program for security issues in Ruby. So as you see, like the maximum bounty is $1,500 for any bug in Ruby on Rails. But still, Ruby on Rails is still Ruby. So if you like, I know some people that have found a bug in Ruby and they won a bounty program in Ruby on Rails. So if you ever encounter any kind of bug, it's not only about posting an issue on GitHub. It's not only about like searching the web or hiding that, or I don't know, it will be used anywhere. The problem is that people are not reporting bugs because people are lazy, because like they want to use it, that bug on other applications. And those statistics were only about reported bugs. No one knows how many of the bugs were not reported and are not being like publicly known and are not being fixed. So coming up to the point, like your code is software and software is broken. Software is broken because your code is broken, because the code you are using is broken, and also software is like broken because you are not thinking about the software that you are using of the other people's code. All right, so let's go to the only slide with a code. Because your software is broken, you can find something like that, right? This is a shitty code. This represents a timing attack on comparison of, example, the pin code or anything like that. Does anyone see any problem with that code? All right, so there is one major problem. If you are comparing two strings, it takes the most time if the strings are equal. If the strings are different on the first character, it will exit early in the comparison. So like this is possible vector attack. And the question is, do you think it's possible to exploit that attack over internet? Having in mind that like comparing strings is quite fast. So the answer is that comparing one character takes less than 1 nanosecond. So it seems that it's not possible to do it over internet because like average latency is like 30 microseconds, which is 30,000 more than comparing one character. And like all that noise with latency makes it impossible to exploit that attack in modern Ruby on Rails server. But if we get closer to the server, we see that AWS EC2 has network latency of 20 to 400 nanoseconds. And if the attacker deploys the code in the same region on EC2, he's going to get this kind of latency, which means that he can perform and exploit your app using the timing attack. The other kind of debug you can have in your code is SQL injection. So there's not only 3 SQL injection types, there's many of them. The most common SQL injection, like this is the title of that slide. So this is actually not possible with plain Ruby on Rails application because active model is validating the input. But still, we're not having only pure model, active model database access in our apps. Sometimes And we all know that sometimes you have to write some custom SQL code. And each custom SQL code is possible attack vector. So even though you're not going to display anything from the database using that code, you can still have blind SQL injection. And blind SQL injection is about issuing SQL command, so injecting SQL command into your query, but you don't see the result of the query, but you can affect the time of execution. So if you put sleep in that command, like conditional sleep, if the password is longer than 6 characters, sleep for 2 seconds. This makes it possible to actually get any field of any table in your database. And it's still there, like over 50% of the bugs are SQL injection. Not only in Ruby, also in C#, in PHP, like in everything, because this is human error and software is broken. There's also one kind of SQL injection. It's error-based, and it can be found in your logs. So your log is not only a ton of text about users, about requests, about responses. It also contains information that are sensitive, like database schema. You can generate database schema using the errors of the logger. So if something is wrong with your app, if there's a bug in the code, and there's always a bug in the code, in the logs you can see information that lets you know the schema of the database. So protecting the logs is as important as protecting the database. There's also one tool, because like finding SQL injection is hard, and you can't really find SQL injection by hand. There's a bunch of tools that you can use to actually pen test your application before you release it. And SQL map is one of the most successful because it has the most attack vectors, it has the most community, and it supports the most databases. So like one tip for you is pen test your code. Try to break your code because your code is broken. The only thing you have to do is to find that broken thing. Some time ago, I was working on a chat application, and like everyone was working on a chat application, right? But the requirement of the client was that the protocol was going to be based on XML. All right. XML seems to be like secure. It's only text. It doesn't have anything, doesn't have any logic. And it's really wrong because like XML has a parser, and parser have features. Features that, if not disabled, can compromise your server. Like this is external entity injection in XML. If user is able to put arbitrary XML code to your communication protocol, he may inject something like that. And this allows to read any file in the system using path traversal or using the absolute path. This was actually found in the older version of Twitter, because the first version of Twitter was written in Ruby. And that's one of the bugs that were found by, I believe it was a Google researcher, and he won like $50,000 for that in Twitter. It was like 6 years ago, something like that. All right, so what you can do about all these bugs? So there are moves and counter moves. Like those were bugs, and one of the counter moves is accept using SQL map and try to break your application. We can also use Brakeman, and Brakeman is actually a tool that audits your race application of any type. There's also one other tool that is aimed to actually attack the servers, attack the infrastructure. It's Metasploit framework, and it's also something that should be used by any developer/QA team. Because QA is not only about finding bugs in business processes, but it's also about finding bugs in security logic. And the easiest solution for you is to scan your gem file using, for example, that bundler audit to find any CVEs about any of the gems that you're using. They have the actual database of reported CVEs of the code related to Ruby. So if you run this command on your gem file log, you're going to have the answer if there is a known bug if the gems. Right, so sometimes you can find something on the server because there's something called deep hiding. So something is publicly available, but still, this is in most cases, this is client requirement that I want to be able to have a report in PDF without login. All right, so let's name it some random name, long random name, put it on the server, and here we have. There are tools that are meant to find such deep-hided things, and one of these tools is Indir Scanner. This is something that actually attacks the server with those attacks and allows you to find any files that are not meant to be found by any user, except the one reporter or somebody like that. Like I said before, logs are sensitive. And if you are connecting to gateway payment, it's very common that any errors on the wire signal, because the protocol is called wire, any errors on the wire signal are being reported to logs, including card number. So this is something that you have to do manually, filtering out logs, not to have card numbers. All right, so you can also think about having HTTPS is a silver bullet because no one can listen to the communication between you and the server. That's not really true. HTTPS is based on TLS, and TLS is using Diffie-Hellman exchange protocol. Diffie-Hellman uses the parameters, and 80% of all HTTPS traffic over the internet has the same parameters because it's based on Apache. So it's not broken yet, but there are farms of the servers that are built only to factorize those numbers, those parameters of Diffie-Hellman. And it's only a matter of time when it's broken. And if it's broken, HTTPS is dead in the form as we know it now, because no one would change the parameters of Diffie-Hellman because it will require a massive update of Apache and Nginx over the world. And there's also one side note that if in your code you are using random number generator to somehow secure something, it's not going to work because random number generator in Ruby is not really random. It's based on time. So if you are generating random numbers time after time after time in very short period, it's possible to guess what's going to be the next number. And this way you can enumerate any random entities on your server. All right, so I want you to have only one takeaway from this talk. And the takeaway is that software is broken. Every software is broken. Thank you. Any questions?
What do you think about register function, which checks the which checks the most, if the user is registering to your service, the function is checking over JavaScript for the password on Twitter and Facebook. If it's the same, then it rejects it.
All right, so 1212. All right. So this is the same case as small password leaked. You are letting some third-party code to read users' passwords. It's not secure by definition. So like, I don't recommend using any password checkers, password validators, password strength validators that are not written by you, or you have not written the code of those of this gem, of this library, because you don't know what the software, what the code of the third-party application is going to do with the passwords of your users. Any other? No, so thank you once more.